So I think being able to read tests is valuable. It can provide some clarity to what's being asked, especially as you move through the curriculum. The tests are going to get more in depth and we'll have multiple steps, but the errors might not be able to kind of break down what exactly is going on in the test. There might be some setup beforehand or some things that are happening that are valuable to see. Kind of like what Joshua and I were just talking about, looking at a test and seeing that, the way that these two classes know about each other in the instance that we were looking at is because, they're passing an object through as an argument. So those methods won't work if the wrong objects are passed in. And being able to see that sometimes can provide clarity. It does take time. It is one of those things that we learn over time to read and decipher. And it is its own DSL, domain specific language. So RSpec is written in Ruby, and the other tests as you go along are written in Ruby, but they're written in a different syntax, which is what RSpec is. Pretty much a syntax of some things that are already created for us to make it easier to write tests. I'm actually looking at implementing automated testing. We have no automated testing where I just started working, and we're looking at doing that. And one of the other people wants to kind of build the library from scratch so it's unique to us. And we're weighing the pros and cons of, using something like well, we wouldn't use RSpec because we're not writing in Ruby, but a domain specific language or a library like RSpec or Mocha or Chai, or I guess Chai is not, it's just an assertion library, but something else, and kind of the pros and cons, because there are pros and cons. But if you have questions, shout them out. Questions about tests, questions about things you've seen in tests, questions about the best workflow for reading tests or things, any examples. Hey, Carly. I just opened my chat window and saw that. So what are tests? Tests verify the code that we write behaves and produces the desired result. You'll find that what we call test-driven development, or sometimes behavior-driven development, is something that's important, but is also something that a lot of companies can't achieve all the time. It's hard to write good tests if you don't kind of even know how to architect good code yet. So a lot of times we'll write tests sometimes after the fact. That's not test-driven design, but we can still get the power of tests if we do it that way. That's also a great way to learn. If you've written or created a project, go back and add some tests to it, and do it that way, kind of the reverse of test-driven development. It's still valuable, and it still allows you to utilize the power of automated testing where, okay, all of my models have tests for all of their methods, or, the main methods. And I know that if I make it, if I change something to one of my models, if it breaks something that's already working, then it's there. We didn't necessarily use the test-driven development format, but we still have the benefit of testing. TDD, big topic. And yes, as it says, you're not going to be writing your own tests for a while. And the concept of writing code or writing tests first, and then allowing for those future changes to know if it's breaking your code. That's why it was developed. The biggest thing with testing that we don't see as much, because we're not building things that are super large, and we might have 5 tests on something. But as code grows, as web apps grow, there are edge cases. There are things that are dependencies. So you might change something, on a login page, and you go through the manual steps of logging in as your user with the new code, and it works. But that code could have broken something 15 pages deep into your app. So that's where the automated testing comes in, being able to do that, finding those edge cases. It can also be its own rabbit hole where you want to test every single thing, which is also can be undesirable because testing does take time too, especially what's called integration testing or sometimes feature testing, where there's a mock web browser being opened, a headless web browser, and things are being clicked, and then you have to wait for those pages to render. And then you have to click the next thing and see if things are actually working the way you want. Those tests are very expensive and take a while. So there is a balance that needs to be achieved, and it's a hard one to figure out. But test-driven development works by writing a test first for a specific function of the code, then write the code to make the test pass. It's what the entire curriculum is. It's test-driven development. I really love that about the program. I've talked to local boot camp graduates. There's a couple in-person ones where I'm at, and they've never seen a test, let alone written a test. I mean, we don't ever write tests, but at least we read them. We understand them. We can say, okay, I know what it is to get tests passing and to make tests fail and to read test errors. Yeah, I think that's awesome. It's also something that a lot of people don't have exposure to from talking to senior developers and people who hire. So it's a valuable tool. So the steps to writing a test: identifying the desired behavior. That's kind of where the term behavior-driven development comes from, thinking about a behavior that you want to do and then turning that into a test. We'll call our popular social networking site MyFace. Name inspired by nothing in particular, nothing relevant anymore in particular, at least. Users will fill out the profile information, year they were born, need to display how old they are on the profile page. We could have a method current age for birth year to accomplish this task. A method will need to take the user's birth year, subtract that from the current year, and return the user's age. The year is currently 2003, and they're born in 84, and we call the method 84. It'll expect a return of 19. Expressing that narrative is called, in code, is called a test. You'll hear assertions, expectations. There's all different types of ways of doing it. If I remember right, Jasmine has, I think, multiple what are called assertion libraries, if I can find where they do these things. Let's go for B. Ruby. I really don't like Jasmine's documentation because I can't ever find what I need. Information, it's just support. Then Chai. I think Chai shows the different types. Assertion styles. There's multiple different quote unquote assertion styles. There's the expect/should, which is considered behavior-driven development. And then there's the assert, which is considered test-driven development. So to see kind of the difference in structure, they do the same exact thing. It's just how one would write them. All right, I think these can be semi-similar. So this is saying, expect a function to not throw an error. So that's using a not. This is saying, assert, it's not okay, everything, this will fail, type of thing. It's really just in how things are phrased, really the wording, like exists. So we set up a variable, then we assert that it exists, and we throw in the variable, and this is what would print in the test. And we can expect probably equals something like, we set a variable, then we say, we expect 1 to equal 1, or foo to equal foo. Like that's kind of a similar way of doing it. So it's really just the syntax of how testing is run. But there's expect should, there's assert. I think there might be one other, if I remember right. There's 3 syntaxes for writing tests. So those are those in a nutshell. But yeah, coding our tests. In an ideal world, we could write code tests like this. I expect the method, and then we write it out. We run the method to return 19. Fortunately, we don't have that. However, we have RSpec, which has their docs as well that go through all of the syntax. And those are there for you. Understanding the test in the spec directory. So let's look at this. Having already taken care of that, let's take a look inside this test. Here we go. So I wonder, is that getting bigger? Yes. Okay, cool. That works. Cool. All tests are located in a spec directory in Ruby with RSpec, what you'll be seeing. The code within the spec directory will be structured certain ways and designed certain ways to test the code. Actual code of our programs, or our solutions to this challenge, will be outside of the spec. Generally in the lib or app folder, typically in Rails, lib folder outside of that, although it can be other places too. And this one, here's our root method. So when we run this test, we're doing require relative at the top. We're loading in this file, and then we're executing a method from that file. This expect age of person is going to run. So we're setting a variable age of person. That's gonna, wait, I got that back wrong. We're gonna set a variable equal to running the method in that file. So because we've loaded this with require relative, we have access to everything in here. So when we call current age for birth year, we get the return there. So age of person, current age for birth year, 1984. So if we pass 1984 in right here, 2016 minus 1984, we can say expect age of person, which is this variable, is going to equal 32, which, yeah, that's right, it would be 32. So this should come back true. So with that, that's that. I've stepped through this some, and I think running this will make it easier to step through what these are. So in all RSpec tests, we get this describe line. And this first line, current age for birth year method. So that's what is going to be showing in the test right here, this current age for birth year method. This is just, you know, printing there. It makes things more semantic for us. But inside of that, we can also put other tests, which I believe we do in this lab. And then it is going to be the specific test. So it returns the age of a person based on the year of birth, and then a do. So these are just do blocks that RSpec is going to do things with based on describe and it and how we start the do blocks. So it's just Ruby. It's all just Ruby code inside of these RSpec tests. Let's scroll down a little bit. Only things that are required in this line of code is describe and do. Sorry, this line of code, describe and do. Then we have the it. It is an RSpec method, just like describe was an RSpec method. And then do is the keyword, or is the, yeah, Ruby keyword. Let's keep on. We went through this and talked about how we're setting a variable and calling our Ruby method with 1984 in it. Then after that, we're using RSpec and doing expect age of person to equal 32. So if we change this 33, save, this should fail now. I will say it will fail, but I know technology can not always work, right? And then we get our typical expected versus got, which is always useful. Compared using, so this is telling us this double equals compared using is pretty much what is going on here with two equals. And then another good place to look when you have failed tests is this line. And it's going to show you exactly where in the test this failure came from, this error came from. So spec current age for birth here, .rb, and then this number right here, 7, is going to tell you line 7. And that can be very helpful when you get into more complex tests that have, age of person, then it calls a method that sets another variable, and you might have, 10 lines inside of a specific test. And that test is failing, but you're not sure where in that test it's failing. So knowing the line number is very helpful. So we know on line 7, right here, is where it's failing. Okay. A test is always going to be about setting up a state with a known result and comparing that known result or expectation to the behavior of your program, thus ensuring that your program behaves as you expected. There are many kinds of tests, and test-driven development and RSpec are very complex topics. Just focus on semantics. So knowing that these files exist, knowing how to look at them a little bit, it's super valuable. Getting used to this and checking our tests and looking at them. This should be 32. All right. So even if you're passing tests, no problem. You don't have to look at them. I suggest take the extra minute and just read through them real quick. Continue getting used to the verbiage. If you see something new, look at your code. Because if you've already written code that passes it, look at the test and say, okay, I wrote this code. There's something new in this test. What is the test looking for, and why did it pass? So the learn command does multiple things for us. And learn if you saw, I just ran RSpec. That is the keyword to run RSpec tests. It automatically will jump into the spec folder and run through all the specs. It looks for a spec folder, then looks for this spec helper. This doesn't really have anything set up in it. It's just standard RSpec configure order default. So it just does things in default order. But it'll look into this spec folder. It'll look recursively. So if there's other folders inside of here, it'll keep drilling down to find every folder, or every file, sorry, that ends in spec.rb. Excuse me, every file that ends in underscore spec.rb. And then it jumps in there and it does its thing. So that's what RSpec does, and learn does that for us. It also does a couple other things, but it will run the specs just like RSpec did. Looks exactly the same or similar, I think. Yeah. Only thing is the seconds change, but that'll change every time. Understanding test output. We looked through some of the test output, but here is a good one, a no method error, undefined method. So let's see if I can change that. Let's get this same error. So I just changed the name of this method, so this will no longer work because the method we're calling won't be there. Okay, here we go. Undefined, or failure error, no method error. Undefined method, current age for birth here. So the test is looking for current age for birth here. However, It's also smart enough to look into the file that we're testing and find this other method that we have that's very similar, but just has one different letter in it. So it throws this, did you mean current age for birth year with one R? I guess current wouldn't be current. And then we get our error or our location. So we see line 5. So we look at the spec at line 5 and say, okay, age, this right here, and this is saying undefined method, current age for birth year. So this, for some reason, you walking backwards, say this doesn't work for some reason. This is supposed to be in this file. So let's go back to our file and look and compare and say, oh, we missed the R. And there's our R. And failed again down here. So the errors are very valuable. Excuse me. And this is why typically you'll get that if you use ask a question or something and people will say, or throw something in Slack, people will say, well, what does your error say? What does your error say? Because it gives so much information towards what's going on. You know, no method error, undefined method, just this. If somebody showed me this error, I wouldn't have to look at their code at all. I could say, hey, looks like you misspelled your method. The test is looking for this method with 2 R's, and your method only has 1 R. So somebody say, oh yeah, I screwed that up, or I missed that. Thanks so much. You know, staring at code forever. We miss letters and dots and stuff all the time. I spent 3 hours trying to find an error once, and it was a F dot was missing from one line, and that was it. Yeah, passes again when we fixed it. Tip, we can run our test suite as many times as we want. It's totally free. So don't think if you're running tests 100 times, you're doing something wrong. That is the best thing to do. Getting errors, getting a new error, getting different errors. New errors are good things. It means we've made a step towards something, typically. Or we know that we're working on the code that is causing the error, which is valuable in and of itself. We know that we're in the right place. We're debugging in the right place. So new errors are good errors. Sometimes, let's change this again. Here, I think this can be a good example. Actually, yeah. So things like, you know, we get our no method error. We're like, okay, so we errored out on line 5 of the test, and then we fix our no method error. Current. And then we run our tests again. We get another error, and it's frustrating, but we look and we say, oh, we're on a different line. We're on line 7 now. It's awesome. We've progressed. It might not feel like we progressed because we still have a fail. You know, it's either pass or fail, but we've moved down in the test. We've moved 2 lines, which means we're making progress. And then for this one, I guess 2017 could fix that to get 33, which is more accurate anyway. So let's do that. And then boom. So looking at the errors and remembering that running the test suite, it's free. When you get into labs that have more tests and you feel like they take too long and you have to scroll so much because of errors and things like that, there is this flag. This works the same RSpec or learn. I just got used to running RSpec --FF. And what that means is fail fast. It's just another abbreviation as FF. And what that will do is the test suite will stop on the first error that it gets. So the first test that fails. I know there's labs, not many, but there's labs that have, 100+ tests on them. So running a fail fast, especially at the beginning, is worth it, because, you know, when you fail the second test, that's, you don't need to run the other 100+ tests. That's just going to take up your time. And I think we all like to be conscious of the time that we're spending. But yeah, run the test suite a lot, get instant feedback, read the errors, they're clues. Big part of programming is simply getting past the current error and getting to a new error. Progressing through errors until your test pass is a very normal development cycle. So we've stepped through reading the errors and getting our test to pass. Okay. Mismatched expectation is what our expected and got when they were different was, or is called. Keep on. What does our program actually do? First, while our tests pass, if we were to run just our program file alone, it seemingly does nothing. Run the command in your shell and you get no output. So what value does that provide? Files and programs like the coding in this current age for birth year are common and valuable. It's not useful alone. And this was something that I struggled with a lot, like doing procedural Ruby and building stuff like this and saying, you know, what's the point? How does this ever help me build something like this, you know, that has a page and buttons and pops out of an IDE and has chat and all these things. Like, I feel like I'm bashing my head through these problems and they're not getting me any closer to where I'm going. But the file isn't meant to be used alone. It's considered part of a library, so to speak, or it's a piece of code that's going to be part of functionality and will be loaded into more complex programs. It isn't that this file doesn't do anything. It does something very significant. It defines a method, and it's a unit of work that is going to happen. So back to our abstraction. Let's go back to our terminal, which we're in, and make a new file. So let's do that. Touch, how old are you? There we go. Put the following code and save it. All right. Copy, paste, save. All right. Run this code with Ruby. How old are you? Oh. What year were you born? 1984. It's not right. There shouldn't be any errors if you copied all the code from the tutorial, but if there are, just read them and try to debug them or ask for help. What this program does is load, not 47 though. What this program does is load the code in our original program, which is here. Then prints the string, so loads the code, prints the string, what year were you born. And we're getting some input, and we're setting it to a variable birth year. We're setting our age by calling this method and passing in this birth year we just got from our user and adding to that year minus 2003, which that's where things are wrong. But we're not worried about that right now. Calls the method, and by the power comes from, and abstraction comes from being able to call this method without having to define it inside this file. It keeps our code cleaner. It keeps our separation a little bit cleaner, And in a lot of the examples that we see in the curriculum, it doesn't make as much sense to do things this way. I mean, yeah, like we don't have to define this inside this file, but it's only 3 lines. Like, are we really saving anything by putting that in a different file we have to open? Probably not. You know, in real life, we would probably put that method in here. But when we're going to have thousands of lines of code, it's better to have those separations. Our tests are only temporarily correct. The second weird thing about the current information is that the test suite and our solution are brittle and can produce a false positive. In the future, our code will break, but our test will still pass. As long as we are relying on hard-coded notions of the current year, our code and tests aren't honest. Imagine the following test making use of Ruby's time class and methods. So here, let's get back into our test. We're going to make our test more powerful. So where is current age for birth year method, returns the age of person based on the year of birth. And we're going to use Ruby's power. We're going to time.now.year. So this is, time is part of Ruby. It's a, I forget what they're called. Module? I think the correct term is a module. Ruby module that is available by default, and you can look, or Ruby class. It's a Ruby class, that's what it is, called time. So when you call time, there's built-in methods, so this will return the current year. And then let's see what this is saying to do. We're bundling in birth here. Answer equals age of person, current age for birth year, and pass in birth year here. Expect age of person to equal answer. Okay. So this test uses a year. Let's see. This test uses the year at the moment the test was executed to compute the accurate result and compare it to the result of the method. So still looking at the logic, but now being able to update the current year in the test and running it properly. Still, it's a better implementation. It still isn't perfect and could break, but it's a better implementation of what we were doing. Minus, oh, that's what it is. I don't think that's needed. I want to fix this. Yeah, there we go. That's what it's supposed to be. I don't know why that was there. I'm gonna put that just so I can fix that. I won't forget to at least point that out. Oh, yes, no. So conclusion, remember for now that you're not being asked to write your own tests. So don't worry about writing your own tests. I know a lot of people really want to learn how to do it. I was one of them. I'm sure you might be too. Don't forget that, you know, it'll come in time. Don't worry about it right now. It's a whole nother rabbit hole to go down. I don't think it's worth the necessary time that it might take. But reading tests and understanding error messages that get outputted as results, something that I did when I wrote a few tests, I think 5, I wrote for one of my projects, was referring back to earlier lessons and looking at how they implemented them. And I honestly copied and pasted. And that's how I got started writing it, and just editing a few things and seeing how things go. And there's a few labs that have, you'll write a test or two, just so that it isn't completely foreign and you can see how to do it. But don't worry about it. Reading tests is super valuable. Writing tests is not something that I've experienced as expected out of new web developers. So don't go down that rabbit hole unless you really, really want to, because it'll take a while to get out of. And then, yeah, resources, RSpec and stuff to look at if you really want to. But read the tests. They're super valuable. They're super helpful. As you get further along, this spec helper might have things. There might be a helper folder inside of spec. There'll be a Rails helper sometimes, and those will have some configuration things that might be helpful. You might see a method run inside of RSpec that says, before each, and it has a method name, and you're like, okay, where's that coming from? And it's probably in a helper somewhere. So looking for those things is helpful too for knowing what's happening in addition to the code in the test. But yeah, that's this TDD RSpec and Learn lab. Close this up. It's pretty cool. You got the beta view. And yeah, I hope that was helpful. That's what I got for this lab. Any questions, Steven?
No, thanks.
All right, you're welcome. Yeah, and let me stop recording. I can't ever find that. There we go.